This is a YouTube video talking about how I made these two little simple lights. That's a direct color. It's like 490 nanometer lights in there. It's like a turquoise color. It's hard to see in the camera. It doesn't come out cool, but it's a really nice color. It's like not blue but not green. It's like a cyan almost. And it's kind of like a wall washer design. It's just like a simple little thing that's meant to like kind of block the LEDs if it's sitting, if you're not standing over it, but projects the light up on the wall and under the ceiling a bit. And then this light down here is just a little light for my turntable because it was so dark in that cabinet and I can't really keep my turntable out because of kittens. See, she's already thinking about brushing on stuff. I usually measure out the lines by taking one of these right angle kind of deals. It's a ruler too, and I'll just line it up at a certain point, and I'll make dots along the way so I can say, alright, that's like, what is that at right there? That's at 2 inches basically, because it's 2 inches from the edge there. I have it locked at the 9-inch there. So that's like at 2 inches, so I would go here and make a dot, and then I would come down here and line it up and make a dot, and do that all the way down. And then it's a series of dots. The more points you make, the easier it is to make it accurate. And then when you just take a ruler and line up, so you're going to put a line through all those dots like as evenly as possible, you wind up with a pretty straight line that way. And then you can do the same thing, for the other angle, for the other side, and you can get some pretty straight lines. Cutting through this 1/4-inch metal with like one of these 4-inch angle grinders. I usually feel like I use them going forward, but with that 1/4-inch metal I had to like go backwards. I feel like it's easiest just to like paint a kind of line. It doesn't even matter if it's that straight, as long as the end is like right where the disc is going to be pretty much. Then you can just look at the back of the grinder on a line that you drew and just follow it, and it's pretty easy to get a straight line that way. It might seem kind of unnecessary to glue the LEDs down before marking everything, but I find that when I try to just line everything up and mark it, or I guess I never really tried to like measure everything out perfectly and do it that way. That would probably be the ideal way to do it, but I usually just like to template everything. I'm kind of like a template I like that kind of style of doing things. So basically I just glued them down, and now I can mark them. If you don't glue them down, the things might move as you mark them, and then if everything's not perfect, you might wind up making a couple holes that are not quite the right spot, and then that'll be a problem. So I like to glue them down first and then mark them. Hot glue is a little annoying on the heat sinks because it tends to dry really quick, but it's nice because it comes off real easy and it doesn't really leave like any residue. So I mean, another glue or something might be easier, but it would probably be kind of a pain to get off. And nothing's really lit. There's a little bit of booger on there. I'll probably just clean it off with some alcohol, but for the most part it just comes right off. I got this XY axis clamp thing, milling clamp it was called, from eBay. This thing is awesome. It's supposed to be like attached to a bench or something, and it would definitely work good like that, and you can actually move around the workpiece. That's what the XY axis stuff is for. There's actually there's a handle here for the one axis. The other one I don't have the handle on right now in case I need to get it close to this bar here. It's really easy to take on and off. And the weight of this thing is perfect for working with a small piece of aluminum. You can just set it, right where you need it, and the weight's just going to keep it where it needs to be. This clamp works good too for the tapping with the drill press. If you're going to tap with the drill press, what I usually do is I take the belt off. Oh, it's not even off. Just take the belt off so the spindle moves free and you don't have to, be extra safe pretty much. and I'll use this like synthetic oil crap, 40-to-1 mix that you usually use for like lawnmowers, and I'll put a little bit of that onto the tip. And that basically makes the whole operation, especially the coming back out, works a lot better. So this is the heatsink with the LEDs lined up, all drilled up and tapped and ready to go. You can see the one for this light's already done. I just used these little, it's basically an M3 nylon washer, but it works on the 440 screws that I use for this. There it is, all soldered up to the LED driver. I'm using this, it's funny, but both of these LED drivers I'm using for these lights were labeled wrong. Like this one says the negatives are the red and the positives the black. The positive that says it's negative on this side is definitely the red wire. So it's probably the brown that's the line as well, like it's usually coded. Here it is, almost done. Definitely lights this up really well. I just use a binder clip sometimes when I'm soldering wires together. If you twist it together and put a binder clip on it, it's like a cheap helping hands to hold everything together for you. Just gotta clean the flux off this crap. This switch is all wired up. There it is, all ready to go. You can see it's a lot easier to see in there now. The camera actually has trouble. It looks like it's way too bright in the camera, but it's really not. It's a nice brightness. It was cool. Before I could never see if I was at the edge of the album or not. I just cleaned it up a little bit with some wire ties. I'm gonna, I think I have a staple gun somewhere. I'm probably just gonna put a staple around that AC cable for some stress relief. I could drill a hole in this metal bracket that I have on the back of this and just kind of knot it through there. One or the other. Staple will be easier. It works pretty damn good. This is actually, like I said, these are running at like 110 mA. It doesn't get hot, but it gets like warm enough that I don't want it to get any hotter than that. I even think ideally I would have split the circuit one more time and had like 6 LEDs split the same way, so the current would have been limited more to each of them. So you can see, like, it's not nearly as bright as that light up there, but for that little spot there, it's plenty enough. So this is my CNC machine robot cutting out a piece for the light here. This is like a little shield piece to kind of keep the lights from blinding you right in the face. I always try to do soldering outside if possible. Such a nice day out. This flux stuff, this is some pretty good flux. I bought, it was like manufactured right when I bought it. I think I got it on eBay. You might be able to get away with not using flux for soldering for a lot of stuff, but with these little solder pads on here, they're just like these metal pads. Like you can solder to them without flux, but do yourself a favor and buy the flux, because Not only is it like a huge pain in the ass to do without it, they're always weak. Like it should be like a weld. Like you should be able to like mess with it and it won't crack. Like if you don't use flux, if you try to mess with the wire, it's gonna crack off of there. So you definitely want to do that. I'm cutting these little short pieces to make the serial circuits. They're all lined up, negative, positive, negative, but then it goes negative here because that's going to be where the parallel connection is. So that'll connect the negative from this circuit to the negative of that circuit. And then these will do the same thing where they're bridged together. And then the positive will bridge. So it's a serial circuit, one serial circuit, and then another serial circuit, and they're both paralleled together. And the input from the driver will come to one of the sides. Like, this design will be coming from this side, so it would go to this circuit and then it would bridge to that circuit, and that's basically your two parallel circuits. And that cuts the say it's a 700 MA driver. When you do the two parallel, it'll cut it in half, so it'd be 350 at that point. And then if you add a third circuit, I'm pretty sure you can add a third. I don't think that has to be even. The serial circuit, the series has to be even, so you couldn't have like 3 LEDs and 4 LEDs. It would have to be even, but you could keep adding parallel circuits and it'll keep dividing that current. So as long as your serial circuit is within the voltage limit, not above or below the requirements. If it's below it, it'll probably burn the LEDs out. If it's above it, they probably just won't light. But you only have to worry about that voltage in the series. As long as you keep that parallel circuit the same, it'll just divide that the current input. So you could use a 3000 MA driver to drive a bunch of 30 MA LEDs if you broke it up enough times. So these are going to be running at 120 MA each, since it's a 240 MA driver and it's being split into two parallel circuits. I think 120 MA is a good number for these, even though they're rated to run at like 300 and 700. The 350 MA I think is what they consider 1 watt, and the 750 or the 700 MA they consider 5 watts. That's usually like way too hot for these. I noticed a lot of the newer LEDs they're coming out with too they'll say on the spec sheet they're only supposed to run at like 80 MA. So I think that's kind of, even these old ones, they run better, cooler, they'll run longer, and they'll meet their life expectancy, or probably greater than that. I usually use this screwdriver to apply this flux. And I usually add a generous amount. It's a messy process, and it's also like the chemicals are not the safest. It's probably good to wear gloves while doing this. I try to just minimize my hand contact with it, but gloves would probably be better. This is a 40 watt, I think, soldering iron. I tried to use the temperature controlled ones, but I feel like I never got them to work right, so I just use this one. This one gets like way too hot if you leave it on too long. Right now it's probably good. At a certain point it just starts burning up the solder and you have to turn it off for a little while. If you've ever done this without flux, you'll see how much easier this is. Just leave it there for a second and it'll all do its magic. Clean this off. Probably don't need new flux since I add so much of it. And just like that, they're all balled up. Try to do it without flux, you will not have as easy as a time. I feel like with soldering, you have all the right stuff and the right temperatures, and it works like magic. And if not, you might think it's like the hardest thing in the world, but you just kind of have to have the right stuff and the right temperatures and all that, and then it's easy. This is something I've been doing. Instead of tinning the wires, I try to put enough solder down that I can just get the wire into it. That's probably not ideal, but as you can see, these are pretty substantial globs of solder there, especially that one. There shouldn't be much problem with just trying to attach the wire to it, especially when I add the extra flux on top. It should help it all melt up good. I feel like the insulation often gets really crappy looking when I do this hold with the pliers method. As a matter of fact, it's already coming through on the side, on this side. This isn't the best idea. Yeah, let's just add some solder on top of that. Not using the pliers is easier on the insulation, but it sucks on your fingers. The slight burn is definitely well worth the results, though. I mean, that looks fine, but like I'm gonna continuity check between these points and the heatsink just to make sure nothing's touching. I really recommend using a longer wire that just would do like a U shape. These tiny little connections are harder to do, at least for me. I'm not good at it. And that U-shaped wire there is, there's kind of under stress because it's bent. If it was a crappy connection, it would crack right off of there. But since it's a good connection, it should be fine. Not the prettiest connection, but it's good. That wire could have just been a little longer. This is not no clean flux, but even the no clean flux, I think you should clean it. I think they just call it no clean because it's not conductive. And technically, you don't have to clean it. This stuff is actually conductive. If you leave it on stuff, it can cause shorts. Plus, it's like nasty. I usually just take a little bit of paper and just kind of put some rubbing alcohol on it and just wipe it out. And usually that's good enough. Like, it's not hard. Gets rid of the marking, magic marker as well. That's a good thing. Okay, so obviously didn't get it right. Just plugging it in, it only lights up the one LED. I figured out what I did wrong, and it was pretty stupid. These series were wrong. The positive, it was going positive to negative, then negative to positive. It wasn't following a path. I think the best way to do it is just think like the positive's coming in here, and then the negative from this one goes to the positive of this one. Before I had the positive of this one going to the negative of this one, basically bypassing this LED, and then giving it the wrong current over here. So, the wrong polarity. I always seem to do that. So the best way to do it for me is to just say follow the positive to the negative. That's going to go to the positive of the next one. The negative of that one's going to go to the positive of the next one. And then that's your series. So as far as the parallel wiring goes, I think the original way I had it wired would have worked, because you see I can put the negative on this side and they all light up. And I can also go to the middle here and put the negative here, and they will also light up. Hey Scout, wanna see the new light? No, she don't care. Ooh, maybe you do. It's not too bright. It's not like gonna hurt anybody's face. What's that thing, huh? So as you can see, they all light up. That's properly set up now. This is just a kind of a, I don't know, the idea is kind of be like a wall washer kind of light. Just something to put on a shelf and change the color of the wall a bit. And definitely the ceiling.